I thought I'd switch it up a little bit. I had a discussion last week with some of the panelists, and rather than do a technical slide deck, which my good colleagues here have done a really good job on presenting the opportunity for cellulose-based biomaterials, I thought I'd present a little bit more about the market and why we're here. So going back a little bit, this is actually why we're here, why we're talking about cellulose-based biomaterials. This actually shows the North American newsprint demand over the last 15 years. Now, most of you guys are probably aware that we don't really see newsprints around anymore. So this basically shows 15 years of consecutive decline in newsprint demand in North America. So it went from 13.1 million tons per year down to 4.5 million tons in the year 2000. It has stabilized a little bit since then, but in essence, it's a loss of 8.6 million tons of annual capacity for a product that Canada, and particular Quebec, was known for making. So the industry was in basically dire straits. So the reality of it was that game changers, such as digital media, smartphones, and other ways that we receive traditional media communications, have completely changed the demand for printing and writing papers. So not only just the newsprint demand, that's basically daily newsprint, but if you look at telephone directories and other sort of communication papers, the demand for them is significantly down. This has resulted, first of all, it resulted in significant job loss and economic downturn, but as a result of that, the opportunity has arisen for us, for companies like ours, to take and harness innovation to expand into new markets and new applications. And we've heard a lot about these the last couple of days. Those are bio-based chemicals, fuels, and materials. So that's why we're here today. That's why, the result of some pain, but a lot of good innovation done by a lot of good Canadian researchers has led to actually the founding of these three companies. So us, Performance Biofilaments, we're a biomaterials company as well. We're focused on the development of cellulose filament technology, very similar to Kruger, based on FP Innovation's proprietary patents. Right now, we can supply tonnage quantities of CFs, and out of our pilot plant in Vancouver, we can actually provide kilogram quantities of modified CFs for development purposes. We're also conducting a plus or minus 30% engineering study for a commercial plant. There's been some news that has leaked about that commercial plant, and it is most likely going to be in Quebec. But the public announcements on that plant haven't really been made yet. So this is about as much as I can share. I'm based in Vancouver. We also have offices here in Montreal and our R&D labs at the University of British Columbia. A lot of our work we actually do via collaborations. So internally we maintain a small team. So my R&D group is comprised of 2 scientists and 2 technicians. But the majority of our development work is done through collaborations. So at UBC, we have collaborations with the Faculty of Forestry, the Faculty of Chemical Engineering through their pulp and paper group, as well as civil engineering, where we do development work. We do some pretty advanced microscopy and sample analysis work at Simon Fraser at the 4D labs, also in Vancouver, or actually in Burnaby. We continue to work with FP Innovations, who actually have created the seed technology, and we're building upon that, creating our own IP, and further continuing to support projects that FP Innovations is working on to further develop applications and process knowledge. And Natalie presented earlier on some great work that they're doing. So we've got some collaborations with NRC as well at their facility in Boucherville. PEC, Polymer Engineering Corporation, is a local lab in Vancouver, a unique little find that we made where right in our backyard we actually found some extremely good compounding and polymer expertise, and we're able to leverage that expertise and expedite a couple of our projects. And right in the middle there we have Fraunhofer. We have a project with these folks where we're looking at making an 85% renewable composite material for the automotive sector. So when I say 85% renewable, I'll get into the details, but our material, the cellulosic material, will be the reinforcing component, and through our work with Fraunhofer and another project participant, we'll be sourcing bioresins, and we'll be combining these 2 materials and achieving, our target is 85%. The original target was 100% biorenewable. But some of the coupling agents, some of the other materials at this point are just not available in bio form. So we revised the target to 85%, which I still think is quite good for a composite material. So we are a new company, but our joint venture partners have been around for a while. We're a 50-50 joint venture between Mercer International, which is a Vancouver-based pulp producer. And as my colleagues mentioned, that the input material for a lot of these cellulose-based biomaterials is kraft pulp. It's typically a chemical-free, a lignin-free chemical pulp. And Mercer is actually one of the largest producers at 1.54 million tons annually. They have one operation in British Columbia, and they have two of the newest ones in Europe, both based in Germany. Resolute Forest Products, you guys may be more familiar with. They have offices in Montreal, and they're more of an integrated forest products producer, everything from forestry operations to solid wood, engineered wood, pulp, paper, and now they're getting to tissue as well. Resolute has 21 pulp and paper mills and 18 wood production facilities throughout eastern Canada and southeastern US. And both companies are actually quite large in producing green power as well. So although we're a new company founded in 2014, we have good backing, both financial backing and basically backing of the company from two large parent companies that want us to succeed. You've seen a version of this picture before in Anton's presentation, so I won't get into the full details. What I will highlight, and again, is where most of these processes do start off with utilizing a chemical kraft pulp to begin with. And you either mechanically or chemically can break down that fiber into its constituents. And again, what Celluforce does is chemically take it down all the way into nanocrystalline cellulose, whereas we can stop, because we're a mechanical process, and we can stop the mechanical delamination of the kraft fiber and customize the properties a little bit based on end-use applications. So I like to present our material as a range between nanofibrillated and microfibrillated cellulose. And a lot of that depends on the actual mechanical treatment and the degree of mechanical treatment, followed by any post-treatment that we may do. This graph actually I left in here. And again, very similar to what Antoine showed, where the green dots are the cellulose-based nanomaterials that we're speaking of today. What I've also included, first of all, I've included the chemical kraft pulp with respect to length and aspect ratio, but I've also included a typical glass fiber, two grades, a milled glass fiber and a chopped long glass fiber, and a carbon fiber, and where they fall with respect to length and aspect ratio. And the reinforcing potential of cellulosic materials, biomaterials was mentioned earlier. And this is where we fit in with the spectrum of what is currently used in the marketplace. So for example, if you look at the glass fiber, we actually have a significantly higher aspect ratio than both of those glass fiber materials, yet we're 1/3 less, our density is 1/3 of that of so 2/3 as that of the glass fiber. So when you look at automotive composites, one of the desired targets is to actually reduce the weight, in particular of the non-structural components. And glass fiber is what is typically used right now to reinforce some of the plastic materials. And here we have an opportunity to provide similar reinforcing ability while providing opportunities to reduce the weight of the component. So I'm going to switch a little bit. So I think that was the last technical slide, or somewhat technical slide. I'm going to switch a little bit and present the market opportunity. Why are there three companies here sort of looking at the same markets? This actually is a synopsis of a study done, and it was published in the TAPI journal, TAPI being the Technical Association of the Pulp and Paper Industry, back in 2014. And to the best of my knowledge, the data, even though it's from 2014, still holds true. Most of these markets are still in development. But they consider these to be sort of known and sort of traditional markets for nanocellulose-based materials. So paper-based packaging, in North America, we've got a potential demand for nanocellulose materials in the range of 1.6 million tons. You scale it up globally, you're at about 5.2 million tons annually. Displacement for plastics packaging, displacements for packaging films, and paper strength additives. You combine these markets together, you're looking at 4.3 million tons in North America and 1.52 million tons globally. These numbers are in that magnitude of trying to displace the capacity lost or the demand lost in some of the traditional printing and writing markets. So it's actually a pretty unique opportunity where if we capitalize on even some of these traditional markets, we can potentially bring back some of that economic activity based on these new materials that we're trying to develop. Now, what I'm most interested in is some of these developing applications. And again, going back to Natalie's presentation, it was highlighted of how we can use both lignin-based and cellulose-based composite materials in the automotive sector. Well, in the same study, again, if you look at automotive body components, a 20% market share represents about 320,000 tons for cellulosic biomaterials. Globally, it's about 3.5 million tons. And this right now, the primary, primary material used in automotive body components is either steel or aluminum. Some of the higher end vehicles do use carbon fiber as a reinforcing material, but there's a lot of work being done by a lot of groups that are looking at both cellulose-based materials and hybrid systems. So a hybrid system would be a combination of, say, a carbon fiber, a natural fiber, say a cellulosic material, and even a glass fiber to make a reinforced web that is impregnated with resin, similar to what carbon fiber manufacturers do right now. And that material would have similar performance yet lower cost to, say, a carbon fiber composite right now. Automotive interior components. This actually is more of the near-term opportunity, where these are both interior components, non-structural, and underhood components that are used that have a little bit more of a performance requirement to them. About 108,000 tons per year in North America. This is just the demand for the cellulosic reinforcing material, and globally about 587,000. Richard mentioned concrete additives. Again, a very large market. The opportunity for cellulosic additives in this market to provide very unique attributes and to basically produce a high-performance concrete material is quite significant. And as we all know that, concrete, for example, the production of cement and the manufacturing of concrete and the delivery of it is the single largest human-caused source of CO2 emissions globally. So some of Richard's data, and we've got similar data as well, has shown a 20% improvement in the performance of concrete. So if you can actually improve the performance and the strength of concrete by 20%, you're not necessarily going to have a building that's 20% stronger. What you will do is have a building that uses less concrete to provide the same performance. So in the manufacturing and the transportation and delivery side of the concrete, a little bit of cellulosic materials can provide a significant economic and environmental benefit to the overall sector. Absorbance and filtration material. As we know, the world is becoming more and more polluted. I see pictures of China and India and other parts of the world where basically, you can wake up in the morning and see the sun, and 3 hours later, because of the pollution caused by vehicle traffic and smog, it looks like sunset. So high performance filtration media is a significantly growing market, and the physical characteristics of the high aspect ratio of cellulosic nanomaterials make them an ideal fit to work amongst other fibers that are used in the industry right now to improve the performance. And then textiles. So here again, in these market and the new developing applications, we have a North American demand of about 1.4 million tons. And I think this is actually a low number. I think it should be quite a bit higher. But because these are developing applications, I'm sticking with the TAPI number. And a global demand of 9.1 million tons. So again, quite significant opportunity for these materials. I'll just highlight one opportunity of why, for example, would the automotive sector want to look at some new materials in their field. And it's been touched upon already. A key driver in the North American field, in particular in the United States, is corporate average fuel economy standards. These regulations basically call for a doubling of the fuel economy. So basically what the North American or the US fuel fleet has to do for every producer is they have to go from 24.1 miles per gallon of fuel consumed in 2011 as a corporate average, and they've got to get to 54.5 miles per gallon by 2025. So quite a significant jump. And the one thing that they're looking at utilizing is advanced materials to reduce the vehicle weight and to achieve some of these targets. That's not the only thing they're looking at. Obviously, electric vehicles, higher efficiency engines. There's a full suite of options available to them, but high performance materials incorporated into their manufacturing processes is one option. Actually, Europe has similar targets. They're based on CO2 emissions. So Europe actually has to get to 95 grams CO2 emitted per kilometer driven from 132 grams. So again, quite aggressive targets, but the automotive sector is working hard and utilizing innovation to try to meet some of these targets. So again, to meet these targets, anywhere from 0.6 to 2.3% improvements in fuel economy can be achieved for every 100-pound vehicle weight reduction. So again, that makes the opportunity that much greater for materials such as cellulosic materials, combined with plastics, because we are a reinforcing material at this stage, to provide significant benefit to the automotive sector. And interestingly enough, the plastic sector is being very innovative on this front. Back in 1970, the average vehicle only contained 90 pounds of plastic per vehicle. These days, it's about 350 pounds of plastic. That's about 8.2% of the vehicle weight, significantly higher in vehicle volume. But the last number I looked at is this growth is expected to continue at 10% annually. And by 2020, about 600 pounds of plastic, various plastics, are expected to be used in the manufacturing of an average vehicle. What that results in is significant opportunity for the reinforcing material that is used in those plastic materials. But it is rare that a plastic is used on its own. It is typically a composite material. And so reinforced composites are expected to, the demand for reinforced composites is expected to grow significantly. So the demand for materials such as ours are going to be quite significant going forward. So switching back to the overall market potential. So if you look at the summary of the previous two slides, we have a total North American market potential demand of 5.7 million tons and a global demand of 24.3 million. And I'm not going to get into price. Price can range anywhere from $3 per kilogram to $30 per kilogram. And you guys can challenge that. But that's what I used for this slide. It depends on the manufacturing process. It depends on the application. It depends on how it's used. But to put it in perspective, if we use, to keep the math simple, if we use a $10 per kilogram selling price, the overall North American market potential is $5.7 billion for cellulose-based biomaterials. Globally, $243 billion. So the market potential is quite significant, and that's why we're doing what we're doing. But the next slide says we're not the only ones. So it actually is a race to get your product into the market. So the three of us have mentioned all sorts of different applications, different potentials. Well, if you look at some of the other market players, Beauregard, like I said, we're not the only ones. So that's why, opportunities such as the ones that, governments create for accelerating development of Canadian-based technologies is quite significant for developing and capitalizing on this billion-dollar market, billions of dollars market, before some of the global competition gets there. So Beauregard in Norway, they've got a microfibrillated cellulose plant. They're claiming that it's 1,000 tons per year. If we actually go to their website, and Richard, I appreciate the pictures you showed, they've got very similar pictures of how they can improve the slump retention in concrete. So it's on their website already. They're already developing that application. Stora Enso in Europe as well, they've got a 100 kilogram per day microfibrillated cellulose plant, specifically targeting food and specialty packaging applications. UPM Biofibrils is looking at barrier properties, using nanocellulosic materials for barrier properties in food packaging, as well as bioplastic. Fiberline, they have operations in Europe and in North America. This actually is a co-refined microfibrillated cellulose, specifically for paper applications, to improve the characteristics of paper. Zelfo in Germany is developing a pilot plan to look at develop micro and nanofibrillated cellulose for food packaging. The list goes on. Jay Rettenmeyer and Son, they've got a suite of applications both for the adhesives industry, for the paints and coating sector, as well as for concrete applications. Diacell, their end applications aren't as clear, but they are developing a nanofibrillated cellulose plant in Japan. Same thing with Nippon Paper and OG Paper. The Nippon Paper and OG Paper, I know that they are looking at more rheology applications, as well as reinforced plastics and some of their traditional markets in the paper. So considering I'm the last speaker today, besides for our open panel session, I'd leave some parting thoughts with you guys. The bio-based economy is here. I've been asked to present a couple of times on this opportunity. And sometimes people ask, well, when is it going to get here? Well, I'm going to propose to you guys that it is already here, but it is a race. It is a race to see who's going to win, who's going to get the gold, who's going to get the silver, and who's going to get the bronze, and who's going to be left to train for the next round. So these new opportunities, again, we presented a lot of them. They are real opportunities. They've been vetted. 6 years ago, 5 years ago, if you would have asked me, a lot of that stuff I would have said, you know what, it's great, it's lab science, it's great scientific work, it's great literature. But you've seen the three of us talk today that we are actually commercializing these applications. So we're well on our way. But with that said, collaboration is the key. Both with existing industry, again, we represent a combination of new companies partnering with existing industry, but there's also other opportunities to partner, both with, for example, the plastic sector, both in the traditional plastics and in the new bioplastics that are coming. And then scaling up. We're all three of us and some of the other companies that present are at various degrees of scale up. So it is important that when we go and talk to potential partners in the automotive sector or in the concrete sector, they don't want to hear about pilot plants, although it's nice to say that. They want to hear about when the commercial material is going to be available and how soon and where it's going to be available and what cost and what are going to be the logistics. So they're worried about more running their business and incorporating this new material into their existing supply chain. So it's important for us to focus on these activities as well. So I will leave it at that. I'll take a seat, take a sip of water, and answer any questions.